Hi everyone, in this video I'm going to discuss about multimap, and this is very similar to map except it can contain elements where multiple keys can have the same values. Okay, so in map we said every key must be unique. Okay, but in this case multiple elements can have the same keys. It's possible to have multiple same keys in case of a multimap, and the goal is same. You want to maintain a key value mapping, and for that we are going to use multimaps. Okay, for example, there is a character B and that's mapped with boat. There is B that's mapped with Batman. Okay, something like this. So you can make a mapping of char and string, and maybe you can do this kind of a work as well. Okay, so let's see how we can work with multimaps, and let me show you one example now. Okay, so what I'm going to do, I'm going to include the header file that is same as map. So header file does not change, it's map only, but the name of the class is now multimap. Okay, so let's say multimap of char and string, and let's say m, and let me do hash include string. Okay, so what we can do, we can take input from the user and make some mappings. Let's say B is for Batman, A is for Apple, B is for boat, A is for angry, and let's say C for cat, D for dog, and E for elephant, something like that. Okay, so suppose you want to store these mappings inside this map object, so where multiple objects have the same keys. Okay, Apple and agree have the same key. So what I'm going to do, I'm going to insert everything in inside my multimap. Okay, so I can say, okay, I want to give 7 inputs. Okay, so int n, scene n, and for int I equals to 0, I less than n, I plus plus, and we can say char ch and string s, scene ch and s, and I can say, okay, insert this inside my multimap. So the function is very similar, it's called insert, and here we will make the pair of the character and the string that will go inside our map. Okay, and now let's try to print the entire map. Okay, so for that again we can either use iterators, or we can use for each loop. For auto p in m, I can just see out p dot first and p dot second. Okay, let's try to run the code. Okay, so you can see we are able to insert multiple same keys in the multimap, and they are not getting overwritten. Okay, and you can also erase a certain key. Maybe you can say, okay, let's say auto it equal to m dot begin, and you can say, okay, I just want to erase this particular key. So let's say m dot erase it, so that is going to erase Apple from the multimap. Or if you want to find a particular key, you can use a lower bound function also. Maybe let's say I want to find out the lower bound of B. Okay, so auto it equal to m dot lower bound. So lower bound will return the next greater than or equal to element that is for B. Okay, so if I do lower bound of B, okay, it is already declared, let's call it it2. So that should give me something that is greater than equal to B. Okay, so some key that is greater than equal to B. So this should ideally give me the key for the Batman. So what I can do, I can say, okay, let's iterate from Batman till, let's say I want to iterate till dog. Okay, suppose I want to iterate over this much part of the map. So what I can do, I can say okay, I have IT2 auto IT3. Okay, so keys like map are also ordered. So m dot lower upper bound. Okay, so upper bound of, let's say, D. So this will actually give me the iterator for elephant. Okay, and this will give me Batman. So what I can do for uh, auto I equals to, or for auto, let's say, IT4, starting from IT2, go till not IT equals to IT4 not equals to IT3. Okay, so let's iterate from Batman till dog and do IT4 plus plus, and I do cout IT4 arrow second. So just printing the names. Okay, so let's run the code and see. Okay, so this maintains a sorted order. So the complexity of these methods, okay, it's going to be logarithmic. So you're iterating from Batman till the dog. Okay, because IT3 is for elephant and we are not going till elephant, so we are going before elephant. Okay, so now you have the iterators. You can also remove some elements by putting a check or something like that. Okay, okay, so this is what you can do with multi-map. Okay, let's also do one thing. Let's try to find a particular element. Suppose you want to search for cat. So what you can do, you can use the find function. Okay, so what I can say, search for cat. So auto it equals to, or let's say auto, okay, search and delete cat. Okay, so we can use the find function. So we can say m dot find auto f equals to m dot find the key. So the key is C, and I can say if f dot f arrow second equals to cat. Okay, then I'm going to remove this entry from the map. Okay, so I can say m dot erase f. Okay, so we can use a find function to check what is present in this. And if we print the entire map now, we will not see the cat. That means we are able to search for an element and remove it, and if there are multiple values mapped with C, then we can iterate over them and see where the cat pointer is. Okay, so search for cat and remove it. Okay, and one thing to note is, in case of map and multi-map, most of the operations that we are doing, like insert, delete, or the find function or the erase function, they work in logarithmic time complexity because because of the underlying self-balancing BST. Okay, so that's all about maps and multi-maps. And if you want to see some of the more methods that are available, you can definitely check out the documentation. So we have discussed the most frequently used functions of maps and multi-maps, and now you can use these data structures to solve problems. Okay, so a lot of problems you can use maps, for example in array based problems where you want to keep account what happened at this particular location, so you can map an index and a value, something like that. Also in linked list, if you want to detect if a cycle was present or not, so you can make a map of node star and bool, whether I have seen this particular node before or not. Okay, so something like that, this you can do. You can keep this address inside the map. Okay, so if you're coming to a node where the address is getting repeated, you can simply say okay, this is something I've seen because this node is already present in my map. That means we are coming to this node twice. That means cycle is present in the list. Okay, so a lot of questions you can solve using maps, and you must learn how to use the maps STL. So thanks a lot. See you guys in the next video.